Hello, welcome back to compiler hacking. We've been working on getting our compiler to be complete enough to compile itself. We are trying to bootstrap this language, and it's really exciting stuff that is starting to come together after a full year of working on Natalie. We're starting to get to the point where it can compile itself, and I think that's just spectacular. So in the last video, we got pass 1 to compile, and I had a little accident last night. I worked on pass 2 and pass 3, and the video was lost. However, you didn't really miss much because it was a very short video, and the work that was done was writing this test and getting all this code indented, which was not, I have to say, very soothing for me, but probably not the best entertainment value for you. It was a lot of just work getting this test written, and it just worked. Like, there was no work to be done. Pass 2 and pass 3 compiled perfectly without any additional work. And so now here we are, pass 4, and I've got the test written. I spared you having to watch me indent code. And this is it. This is the final pass of our compiler. There is some other glue code that we'll have to work on, and probably in another video. But this is the final big step before we start to really see the dominoes fall into place. Or is that the cliche? I don't know. Everything starts to fall into place. So what we're doing today is trying to compile this AST, this intermediate AST, into this C++ string. And this is the final step before it gets passed to GCC or Clang. And yeah, I mean, what else is there to say? This is the final step. And this test, if I run it through Ruby, test Natalie compiler test, works just fine. If I run it through Natalie, then we should get a failure. And I already know what the failure is, but drum roll. Oh, it's a big old stack trace. But the failure is undefined method gsub for, even though this says an array, this is actually a string. We don't have a gsub method, and that's just because I haven't written it yet. So in this video, we're going to work on that, and then I'll see how far I get. Maybe that's the last piece, or maybe there's something after that. But we're definitely going to work on gsub. We do have sub, but we don't have gsub. So let's just get started on that. And before I forget, because I always forget to do the bindings, I'm going to do the binding right now and put that right here. Gsub. Yeah, the binding is just what ties the Ruby side to the C++ side, and I don't know if I actually ever made a video about that. Probably should explain how that works. But we have the header here. I think this is the signature we want to support. We just want to worry about pattern replacement. We're not doing pattern hash or the block version or the enumerator version. So a lot more work to be done, even if we get this to work, because in our pass 4, the only place we have gsub is right here, and all it's doing is getting rid of some non-alpha characters. So really simple. I mean, I could even rewrite this one line of code if I didn't want to do gsub, but I don't know, gsub's kind of a nice thing to have, so we'll just make it happen. And I did do a little bit of work extracting sub into, I should probably rename this sub regex sub. Let's call this regex sub, because that is just a little bit confusing. Regex sub regexp. You know, I really don't love that Ruby calls it a regexp with a P, but that's what it is. So I extracted this branch of sub out, and I made it its own function so that we can reuse it for gsub. And I'm not going to do everything today because I think it's going to be a little bit boring if I do, but let's do this right here. Let's say this If the find part, so if I have in Ruby, if I have, foo, gsub, foo with a string, that's a different path, and I'm not worried about that today. So I'm just going to say not yet implemented, but otherwise, let's just copy this. Should have just copied the whole method. If it's a regex, then we're going to do the thing. And let's write a test. I should have done that first, but got a little bit of ahead of myself. Yeah. String test sub. So let's copy this test. gsub returns a copy of the string with all matching substrings replaced, or something like that. And let's do something different here. Let's say the string is foo bar. Yep. And the gsub of that, I'll say we're just going to replace foo with bar, should equal bar. I should have done buffalo, whatever that is. Yeah. And so if I run that through Ruby string test, make and bin Nelly, give that time to compile, and then we can go over here and talk about this. So what are we going to want to do? So in Ruby, if I have foo bar, and I do gsub foo with food, let's say, no, I say foo. We don't want this recursively matching. So it's going to keep matching until it doesn't find foo anymore, but it doesn't match the whole string every time. So the first time through, it's going to find this foo right here. It's going to replace it with foo, and then you get foo bar. And then we're going to run another substitution, and we don't want it seeing this foo or this foo, because this region right here has already been replaced, and that would just get stuck in an infinite loop. Just making sure this did fail. Yep. So we need to match it starting from here. Once the first replacement is done, then we only need to search and substitute for what's left of the string. And so that's the main thing to keep in mind, I think. So the reason this replaced the first foo is because I basically just copied the code from sub, and now we need to work on getting it to replace that one. So let's look at this. How does this work? If we come out of this and our match object is still a null putter, that means there was no replacement done. I don't think I want it doing this duplication here. My dog is going crazy. I don't think I want it doing the duplication here. I think we want, let's just return this unchanged. And then up here in sub, I want to say auto result equals that. Actually, I'm just going to put it back. I'm just sort of doing an optimization right now, and I don't want to get into that habit quite yet. Okay, sorry. Gotta get my thoughts out. Gotta say something. It's really hard when you've been doing programming for a while to express the thoughts because I they don't they're not very linear in my mind. Like I'll make a thought and I won't be able to even finish a sentence before I've already moved on to the next thought. So that's kind of hard thing for me to do. Doing these screencasts is completing a sentence before moving on to the next thought. Anyway, I just went down a rabbit trail of thinking I should get rid of this dupe, but I'm going to resist that urge. That's optimization that I shouldn't worry about yet. Anyway, so I haven't really changed much yet, but I believe we want to say do. This will be in a do. And we'll say while match is, actually I think this needs to be in here every time. No, match equals null putter. So we'll reset it to null putter every time. And we'll say while match is not a null putter. I could just leave this part off, right? Yeah, let's just do that. So while there's a match, we're going to keep doing the substitution. And we're going to say string value result is this. I'm going to say result is this, and we're going to return the result. Now we have a problem. This is going to get stuck in an infinite loop. And I mean, is there any harm in just running it? I don't think so. I don't think this will ever finish. It might, yeah, it might segfault because it might just blow the stack. Actually, it wouldn't blow the stack because it's just an infinite loop. Yeah, it's just going to be churning away. So does our regex sub need a way to know how to know where to start? I think it does. So let's pretend that we had a size t start index and it's always 0 by default, and string value HPP. We'll have to do it over here too. Size t. Are you happy now? Yeah, you're happy. Okay, and why? Too few arguments, but I gave it, oh, I think I can't do the default here, maybe? Is that it? What did I do wrong? What did I do wrong? So I have a size t equals 0 there. Now are you happy? Okay, that's how you have to do it. And we'll just say size t start index is 0 here, and we'll pass that in, start index. And we're going to need to increment that somehow. So that's one step. So let's do to'd increment start index somehow. So that's one of our to-dos. The other to-do is use start index somehow. So these are my two big old fat questions of how do I make this work? And right now we're delegating the match to, we're sort of reversing it. Instead of doing string match with regex, we're doing regex match with this string. And so let's go look at regex. Regex value HPP. Match is right here. Oh, my jump to definition is not working. I keep thinking I'm going to get that fixed, but I haven't done it yet. Is there any way we could pass in a start here? Search. What does search do? Oh, it does have a start. Fancy. Okay. So if we pass in the start here, it's overloaded with the start index. And we're not passing in the start index. So why don't we just do this? Size t start index. And we pass in the start index here. And then we go back over to here. And we go to match. And we say size t equals 0. Does that make you happy? Yes. Okay, so nothing should have changed. In fact, I'd like to run the regex tests just to make sure I didn't break anything. Time for some tea. Okay, I didn't break anything in the regex code, which is great. So now I think we can start passing in the start index here. Okay. So that just leaves us with this to do. How do we increment the start index? Well, we're setting the match object and match data value header. What does it have? Does it have a size? A size is how many groups it has. It would be really nice if we had a length. How do we get the length of the match? I believe we can do match data value CPP. Group. So it's basically this right here. Okay. So it's this. Yes? Return. And this is the 0th grouping. So the way the regular expression engine works is you get this region object back, and region has beg array and region has end array. And the 0th item in the array is the whole match of the entire string match. Whereas group 1 would be like if you were trying to match foo, something in parens, and that would match food, right? The D is the first grouping, and that would be the 1 here. Whereas 0 would be all of the match, would be the whole thing. Food matches all of it. And the same thing for end. So that gives us the index of the beginning and the end. So I think if we just subtract beginning from end for group 0, we get the length of the whole match. And now, maybe, if I did everything right, I can just increment by match length, but only if match is not a null putter. I'll say if match, then do that. I don't know. Who knows what I'm doing, really? Sometimes you're just trying things and throwing spaghetti at the wall and seeing what sticks. That's how I program. It's highly technical. I didn't break regex test. I think I already checked that. But string test, does it work? Does it work? Does it work? Does it work? Or does it get stuck in an infinite loop? Oh, it did nothing. Well, that's new. It did nothing. Huh. Fascinating. Oh, so I think I need to do results like so. I need to call regex sub on the result, but result isn't anything yet. So the result is going to be this. What were you complaining about up here? Okay, weird. Okay, does that fix it? It does! That's awesome. String test. Sweet. Okay. Now what if we replace it with foo foo? Or no, replace it with foo foo. Now what should we get? We should get foo foo bar, foo foo bar. Yes, and it should not get stuck in an infinite loop. If we did everything right, it should not get stuck in an infinite loop. And it gets stuck in an infinite loop. Well, this part here is wrong because we're not changing the index by the length of the match. We're changing it by the length of the replacement. Of course we are. I wish I didn't have to do replacement as string all over the place. So let's do this. Let's call this replacement value. Call this replacement value, and then we'll do string value. Replacement is replacement value as string. So I don't have to keep doing that. Does that fix it? Foo foo bar, foo foo, foo bar. Okay. It's still not quite right. Okay, I'm gonna have to puzzle this out here. So if I have foo bar, and I'm at the 0th index, and I do the first replacement, I get back foo foo bar, foo bar. That's after the first time through this do while loop. And then I want the index to be 0. 1, 2, 3, 4, 5, 6, 7. I want the index to be 7. If I do replacement length, that's 7. So that's correct. Okay, let's do another cycle. So the next cycle should return foo foo bar, foo foo bar. This is like the dumbest test. I want the next index to be, so this was 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I want this one to be 19. And so I have 7 here. Oh, yeah, that's definitely not going to work. Yeah, that's definitely not work. So it should be the start of the match plus the length, I believe. Match group data value HPP. Is there a group? It'd be kind of nice if I could get just the index. What does Ruby have? If I do foo dot match foo, we'll say bar foo. Okay. Oh, I'm not in IRB. There we go. Bar foo dot match foo. I get a match object. And if I do dot index, is that a thing? No. What methods do I have? I have, end, offset. Oh, that's kind of neat. Turns an array. So that's the fascinating. Okay, that's interesting. Begin. Oh, look at that. The expose, the begin and end. Oh. Nice. Very nice. So right over here, I can do, I don't know if it's an int. It's probably a size t. It might be an int. Size t. Wait, what does index do? Oh, that's exactly what I wanted right there. Oh my goodness. Okay. I'm just blind. Okay. Group index of 0 plus that. Does that get us a little closer? As I recompile every time. To recompile the whole project. I have done something wrong with my headers so that when I touch one of these headers, it causes everything to recompile. Not ideal. That fixed it. That absolutely fixed it. Value HPP. Nope, string test. What's something else that we can test? Let's replace bar with foo, and we should get foo. How many foos should we get? 4 foos? I mean, that shouldn't be any different, but since bar is not at the beginning, I just think there's a potential for some off by 1 error or something. So that's good. What else? Oh, we should test back references. What's the back reference I did up here? It's a little bit dumb, but I'm just going to do this. ABC. It's going to match a letter, and then it's going to put the letter, and then it's going to put a dash. And so we should get A dash, B dash, C dash. Yeah? Is that a pretty good test? Oh, and gsub. I think that's a pretty good test. Let's run it with Ruby just to make sure. Yep. Make sure I did that right. Definitely didn't quite work. Now, why is that? I think I do have an off by 1 here, maybe? Okay. So let's do it this way. ABC, gsub, A through Z, prints. I think I gotta double back slash this baby dash. And let's okay, so that seems to be working. If I run this through Ruby, I get what I expect. Okay, so what we're gonna do is right here, I'm gonna say printf start index equals. Every time through there, we're gonna print it, and then at the very end, we're gonna say final start index. And let's see if that is what we expect it to be. So 0, 2, 6, 0, 2, 6. So let's say we have ABC, and then the next time through we have A dash BC, and the next time through we have A dash B dash C, and then the last time through we have that. So the start index here should be 0, and then you get back here, 0, 1, 2, it should be 2, 1, 2, 3, 4, should be 4. Why did it skip 4? 1, 2, 3, 4, 5. And this one should be 6. So it skipped the 4th index. Well, my logic here is still not right with this start index junk. If I get rid of the -1, I know that's not going to fix it. 0, 3, 9. So it was closer with the -1. So let's print both of these. Printf match index 0 equals match. Oh, let's just paste. There we go. Printf replacement length equals are these what we expect them to be? Replacement length is 3. Ooh, the replacement length is 3. Okay. The replacement length is 3 because I'm counting the raw. The raw length. This should only be 2. And the only reason that -1 worked was because of that. Bummer. Okay, so I don't think I need these printfs anymore because I'll keep this one. How do I get the length of the replacement? So regex sub down here, it does expand backrefs. I'm just gonna have to have another pointer. String value expanded replacement. And that's kind of getting big. Might be time for a struct. But I'm just going for getting it working right now. So do string value pointer star. No semicolon there. Expanded replacement. We're gonna say this expanded replacement, but this is deref expanded replacement equals this. So now we can use the actual replacement value that was used to get the length. And hopefully our numbers will match. What have I done? Oh, right. Up here. I don't actually care about it here, but yeah, that's fine. Okay, so now why do you need to recompile everything? All I did was change string value CPP, and you should not be recompiling everything. Okay, still got the wrong thing. So let's bring back our printf. 026. This is still not right here. This index 0 is incorrect. Maybe I don't need the plus equal? I have a hunch, but I don't know how to visualize that. Interesting. Let's see if our other tests still pass. Actually, let's see if all our tests pass. If so, then yeah. Okay, so I was incrementing where I really should have been using an absolute, like the index plus the replacement length. Okay, that makes sense. I wish I could explain how I jumped to that conclusion. That's one of those non-linear thoughts that just popped into my head. But yeah, it works, right? It works, and let's go. I don't actually want to commit that because I'm not using it. This I do want to commit. Yes, commit. Yep. 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 Definitely yes. Nope, not ready for that. Not ready for that. Yes. Okay. Add, let's see, start work on string gsub. There's still a lot more to do, but it should work now. And we can do compiler test. It's taking its time. It's not fast. Okay, wrong number of arguments. Given 0, expected 1 to 2. Pass 4, line 218. 218? 218. 218. I just can't type it. Context size equals 1. Oh, that hurts. That hurts. Okay, let me show you why this is a problem. This describe is something in our test suite, this describe method. And context is an alias for describe. So obviously the code inside of here in the implementation should not be calling code in our test suite. So there's something wrong in our method resolution where we're looking up the method and we're getting the wrong one. Well, another fascinating thing is that the only two contexts here, come back to me. Where were you? Right here. There's only two and they're right there. So where's context defined? Oh, it's defined in sex processor. Oh, yes. We don't have a context. That's exactly why. This is not as bad as I thought. Sex processor. We don't have a context, but we can fix that. Adder reader context. Is this? So every time we go inside of a process, here we're gonna say at let's do context AST sex type, and when we come out of it, I guess we do context pop. Result, return results. I'm not confident about that, but it might get us closer. Okay, got a new error. That's good. Unify method each for nil pass forward line 210. 210. Body each p body 0 -2. Maybe we don't have negative indices yet, but we'll just do some printing of that. Oh man, it's doing some stuff. Okay. It was an empty array. If I have an empty array like so, and I say zero, -2, I get an empty array. But in Natalie, if I have an empty array, oh goodness, and I do a0 ... -2, I get back a nil. So that's a bug. It's just a plain old bug. This should be returning nil, or sorry, an empty array. So that means an array value. We have this method ref, value cpp ref right here. Let's go to our test. I don't call it ref though, do I? There it is. Returns a new array. Nope, that's not it. There we go. Returns the item at the given index. This is the range version. Returns a subarray with the given when given a range. But if I have a equals this, and I do a0 -2, should equal an empty array. And that's gonna fail. Let's just do this array test. Make and bin Natalie array test. So this should fail with Natalie, and we'll just fix it. Shouldn't be too hard to fix. Nil should be an empty array. So where do we return nil in here? If index is less than 0, oh, that's not it. So this is this is some gnarly code that I'm not proud of. What are you complaining about down here? Okay, I don't know. And this is the only place that we return nil. I don't think we should ever return nil here. So let's say I have a equals this, and I do a 100 to 101. Oh, it does return a nil. What makes it change to a nil? Weird. What's the distinction? I mean, there's clearly not there's no 0th element. -2 dot dot 0. Is it just... I don't know why Ruby does that. I guess it's a special case for 0. If I don't know, something here. So if the begin object is 0, then return a new empty array. Else return that. I don't even need the else. I'll just do that. Just gonna put this in here. Say note. Not entirely sure about this, but 0. But range beginning with 0 seems to be a special case. What's wrong with that? I don't know. What's the little, I need the little shruggy guy. Shrug emoticon. This is really lame that I always Google this when I want to paste it. Probably shows how old I am. Okay, does that fix our test? That is just puzzling. Why would the 0 make it return an empty array, but everything else returns a nil? I don't know. Okay, we're going to commit that. If using a range subscript, fix array subscript not returning array. Sometimes this is weird. Seems that Ruby returns an empty array. It's a special case when subscripting with a range that begins with 0. Probably needs more investigation. Okay, well, that will get that working, and let's commit that other thing. Add context to sex processor. We don't want to commit that, but we want to keep that. Okay, so everything else is just that test, compiler test. And I'm out of tea, so I think we're going to have to wrap this session up. And I mean, we might be close. I don't know. We'll find out. Okay, got a new error. Undefined method empty for new 7, which is a string. Okay, we could do an empty method for string. I mean, that's not hard. Bool is empty env. That's just a bool. Yeah, I'll just do that. And I can just say m length 0 return. And I only need a binding for that. Empty is empty. No args, no environment is passed. No block is passed. Oh, this thing is crawling. And it returns a bool. Okay. Oh, I didn't write the test for it though. Start with, we're going to write a real quick test here. Empty. Returns true if the string has a length of 0. Empty should be true. X should be false. Okay, so let's do our string test. Gotta recompile everything. Gotta fix that. Okay, let's commit that. Yep, 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 yep. Nope, nope, yep. Okay, add string empty method. That was pretty easy. Compiler test. Okay. Will it work? Will it work? Undefined method. Oh, dir. Pass 4. Yeah, that's going to be a little bit more work. So let's call it good for today. We made some good progress. We have a dir RB here, but it doesn't do anything yet. It definitely doesn't have, it needs this method, which would take a, like a glob pattern, and it needs to do something. And I think I'll need to have some C++ code in here that lists directories. And I'm not even sure, what is the API in Linux for listing directory? Yeah, I don't know. So I get to learn how to do that, and we'll do that in the next video. So, hey, we made good progress. We're getting past 4 to, getting it to compile slowly. The syntax compiled is just when it's actually running. Now it's running into methods that we don't have. So that's pretty cool. So I don't know. What else is there to say? Thanks for hanging out with me on this cool session of getting our compiler to self-compile. Making good progress, and I appreciate your encouragement. And if you see anything I did stupid, please let me know. I'll see you next time. Bye.